Hello and welcome to our webinar today. The topic is how to reduce downtime with digital twins and predictive maintenance in industrial gear units. My name is William Arnott. I'm the editor for the Australian Bulk Handling Review, and I'll be hosting today's session. I'm also joined by 3 industrial gear experts from SEW-EURODRIVE. The presenters today include Guido Wagner, who is the National Industrial Gears Product Manager at SEW-EURODRIVE Australia, Leandro Pereira, who is the Business Development Manager for Industrial Gears at SEW-EURODRIVE in Queensland, and Tamim Badawi, Group Manager, Product Management for Industrial Gears, SEW-EURODRIVE in Germany. Thank you for joining us today, gentlemen. Now, onto the topic. Bulk handling systems are massive and complex, with many moving parts. If something goes wrong at any point, there's a chance it could escalate and lead to unexpected downtime. Not only can this create potentially dangerous situations, in certain sectors like mining, this downtime can cost an operation millions of dollars in damage and even more in lost productivity. The traditional way of avoiding downtime can be slow and not fully reliable. In a lot of cases, this is just because you don't have the information necessary to catch the problems before they escalate. New technology and the Internet of Things have allowed bulk sites to massive amounts of data that can be fed into cloud-based predictive maintenance systems. Using complex algorithms, you can find out what is happening across your system much easier than ever before. However, unlike other predictive maintenance, SEW-EURODRIVE's DriveRadar uses digital twin technology to accurately determine the service life of components. In this webinar, the presenters will discuss how this technology can provide an overview of multiple assets, as well as show the historical information on each critical component. There'll also be a live demonstration to showcase the many features of the DriveRadar IoT Suite. At the end of today's session, you'll also have the opportunity to ask our panelists any questions you might have. And a recording of today's session will also be made available to attendees. And with that, I'll hand things over to Guido.
Well, thank you, Will. And hello, everybody, and thank you for attending today. My name is Guido Wagner. I'm the Industrial Gear Product Manager at SEW in Australia. And before you will be hearing from Leandro and Tamim about DriveRadar and how it works in some detail, I'll be talking a bit broader about predictive maintenance concepts, which concepts there are and when to use which one, and basically how DriveRadar fits into this. First, I'd like to talk about maintenance concepts in general. A study conducted by Vanson and Byrne of 450 industrial companies has revealed that in the last 3 years, 82% of the companies surveyed had unplanned downtime, and 72% made preventing failures their highest priority. 70% had no information about when maintenance was due, and 87% found predictive maintenance absolutely necessary to be competitive. So what condition monitoring and maintenance concepts are there? This is a little extract from a German standard DIN Euronorm 13306, and it sort of shows what different levels of maintenance concepts there are. So the lowest level obviously is breakdown maintenance. That is when the machine is operated until it breaks down completely unplanned. Then the next level is so-called preventative maintenance. That is when the machine is replaced after a prescribed operating time, irrespective of it being broken down or not. The next level is predictive maintenance. Through analysis of measured data, faults can be predicted and be considered in maintenance planning. Proactive maintenance means reasons for the faults are determined and possibly eliminated. And the highest level is prescriptive maintenance. That is when the prediction adapts to changes in the operating behavior of the machinery. There are different condition monitoring and maintenance concepts. Without any digital support whatsoever, the staff would rely on their senses and their experience to identify any faults in the equipment. Then the first level of computerization means stationary or mobile sensors provide raw data. The perceived state can be quantified. Visibility and connectivity. Data is continuously collected and transmitted. The result is a digital shadow with current status values. Transparency. The system can assess whether values are good or bad. The correlations between operation and maintenance can be analyzed retrospectively and can be used for a systematic adjustment of the maintenance. And the highest level is predictive ability, where future scenarios can be predicted and options can be evaluated based on this to be prepared what will happen in the future. This is from a study of Roland Berger from the Deutsche Messe. This reveals that the benefits the customer values from smart maintenance. One of the values is transparency about the condition of the gear unit. You have the reassuring feeling of knowing that the gear unit is working properly and you're informed if that condition changes. Early detection of faults, so you can plan ahead instead of just firefighter missions, just putting out fires when things happen, and be reactive, be more proactive. Faster maintenance and reduced downtimes. You already know before you open the drive what sort of service is required. You can prepare yourself to purchasing the right spare parts. Optimized stock keeping is another benefit. Again, mainly with spare parts and tools. You can prepare for the downtime and the maintenance, and targeted optimization of the drive. So any problems that were identified during the condition monitoring can then potentially be eliminated. About maintenance strategy, not the same strategy applies to every plant or product. There are different decision criteria that you would use in order to decide what is the best maintenance strategy for you or your plant or your equipment, your asset. Generally, a matrix is being used where one dimension is the damage being done if that equipment breaks down, and the other dimension is the probability of the occurrence of that equipment breaking down. And clearly, the lowest level here is that there's not much damage when the equipment breaks down, and it's also even unlikely to happen. So that would then be a reactive maintenance strategy, would be the correct one to use. Whereas on the other hand, of course, if the probability is high and the damage is high, then a proactive maintenance strategy, predictive maintenance strategy is essential. So decision criteria would include the value of the process outcome, so basically the losses if you can't produce, the sensitivity of the machine or the component, that's sort of a likelihood, how likely is it to break down, availability or redundancy of production lines, do I have another line or two or three, does it all go down or only a percentage, material buffers, time to repair, cost to repair, and of course also the knowledge and experience with the machine. If it goes down, can we repair it? So different maintenance strategies in the one factory are not unusual. So you may find that you have in the one factory several components where you are just reactively maintaining them. Like if it breaks down, you fix it, otherwise don't worry about it. And other very critical components where you absolutely must have condition monitoring in place. Now I would like to talk to you about Industry 4.0. This is one of those buzzwords going around, and the difference between Industry 4.0 and the Internet of Things. Some people think it's the same thing. It's related, it's not the same thing. Industry 4.0 and the Internet of Things. So everybody knows the first industrial revolution, the industrial revolution, where water power and steam power and the mechanization of things turned things around for us, and we've become more productive. Followed by what we call the second industrial revolution, which is the mass production and assembly lines, which was basically made possible through the use of electricity. The third industrial revolution is computers. So basically the automation of production lines. And last but not least, the fourth industrial revolution, Industry 4.0, are cyber physical systems. And this can be absolutely anything from augmented reality to the Internet of Things. So that means the Internet of Things is actually one small part of Industry 4.0. And the Internet of Things means that any device or any person or any plant can be connected to any other plant, person, device at any time, any place. So this connectivity, that is the Internet of Things. And this brings me to DriveRadar, because DriveRadar is exactly that. You've got a smart product. Your gearbox becomes a smart product. It's connected. The IoT Suite is the software behind it that will actually allow you to monitor your smart product, being the DriveRadar gearbox. A digital twin is a virtual map of reality. It's very similar to, say, Google Maps, where the map is a virtual twin of the world. It's just a digital copy of what is out there in reality. And this can benefit already in the developing stage. So digital twins can be of assistance during the prototype stage to understand the product before it's even built, or for simulations of a real life asset. Through sensor technology, the digital twin can compare itself to its real life counterpart for a constantly updated forecast. And last but not least, what everybody has been waiting for, DriveRadar IoT Suite, which is putting everything I've shown you today about the Internet of Things and maintenance concepts of the highest level into a reality. And I would like to hand over to Leandro to show you just how DriveRadar IoT Suite works.
Good afternoon or good morning for those that's in different locations. But again, thank you for joining us. Well, my name is Leandro Pereira, so I'm the business development manager here in Queensland, and I'll be trying to show you how the system works, what the system is, and then at the end, as everyone already mentioned, we're gonna have a live presentation, a live demo. All right, so to avoid issues with broadcasting, I had turned my camera off. I hope that's fine for you. So going back to what Gita was saying, it doesn't take too much to run into a big problem. And to close the gap between the best maintenance practice with the current condition of the equipment, we can use available technology to minimize downtime and increase productivity. So I'd like to present to you our DriveRadar IoT Suite, designed to set new industry standards for equipment where it matters most. So our vision is to create a truly smart, connected system that combines the technology with digitalization or digital twin to produce a future of the predictive maintenance. So the idea today is to give you an overview of the system and show the key functions and demonstrate how the system sets us apart from the usual condition monitoring. Hopefully it opens room for discussions at the end, and we'll be here to answer any questions. So this is a glimpse of the system. It's a standalone solution that operates on its own network, so we don't require any connection from your infrastructure. And it's designed with a fully secured data transmission to the SEW data center. The information and reporting are accessible via online platform developed with a comprehensive authorization concept. The system is capable of providing a true diagnostic and the expected service life based on running conditions. So I'm going to break down the system into 5 parts. So starting from the sensors, We use an array of high quality sensors selected to the Australian environment conditions. And we monitor things like operating hours, input speed, vibration response, oil level, oil sump temperature, oil viscosity, the electronics and ambient temperature. But we also have 3 auxiliary ports available for future or additional sensors if required. So moving on to the Edge processing unit, it's a plug-and-play system. So we don't require any programming in your end, and it's ready to use industrial computer equipped with a LTE modem or Ethernet TCP IP comms. So it collects the sensor's data, encrypts and transmits to the SEW data center via our LTE mobile network. So again, we don't require any connection from your network. So once the data arrives at the data center, so behind the scenes, we have a complicated algorithm that analyzes the collected measurements, and it enriches the data with the specific information from our database or the digital twin. And the outcome is a fully integrated and complete prognostic of all internal components and a precise prediction of the remaining life of the equipment. So the remaining life or service life forecast enables you to optimize the utilization of the assets or to replace components before they calculated end of life. So then moving on to the DriveRadar IoT Suite, we'll explore this on the next slides. So this is, if you point your camera to this QR code, it will take you to this gearbox, which is currently sitting in Germany running for this live demo. So the DriveRadar IoT Suite provides you with a fast online overview of the current condition of all your assets across multiple sites, including the GPS location. It's a user-friendly and intuitive platform available for iOS and Android. It provides users with an easy visualization of on-time faults detection and for a better forecast of maintenance and shutdowns. So again, it would minimize downtime and of course maximize productivity, and built with enhanced push notification methods or different ways. So this is the front screen of the system with the equipment list. So it's easy visualization of all assets, current status across all register sites. It's fully customizable to your needs. And once you select one of the equipment, it will bring you to this screen that enables users to visualize a complete overview of the internal components. So things like live measurements, run information, and its live forecast. And also includes a direct link to our 24-hour service team on a click of button. So this is what set us apart from the traditional condition monitoring. So the forecast method. So we're using machine learning technology and clustering method to detect different operating modes, and that results comes into the algorithm that runs and analyzes and transforms a vast quantity of data into a predictive intelligence. So by using this self-learning technology, it improves the precision and offers entirely new levels of availability, safety, and predictability of long-term flaws. So, and that removes the uncertainties that traditionally characterize the old-fashioned condition monitoring. So this system provides and equips users with a groundbreaking forecast and on-demand live readings that supports the maintenance and planning. So on your screen, you can see an example of forecasting for bearing and gearing components. A forecast also the live measurements. So I won't go through this, but later on, Tamian will go through with you and run this sort of reporting. Here's another example for the remaining oil life. Again, it's taking into consideration the running conditions, the mechanical properties, and other factors such as oil temperature, for instance. In all these reportings, we have it's available threshold settings, which again will be able to trigger a comprehensive notification way, so we can push notification through emails or push through your smartphone. And also, I haven't covered this yet, but through a OPC-UA, so we can push status to your automation system. With that, we have different types of users. So we have, for instance, a management type where they can see a full spectrum of the system, such as activity history, system availability, assets list, and other functions, as well as we have a on-site users that gets the notification through for instance, an iPhone or an iPad. They can easily identify the issue by using the asset selection, and they can evaluate the issue. Then they can see the actions recommended, which again, we made all documentation available for an easy maintenance process. So this is a type of the users. Now, if I may, I want to go back to the last but not least. We also have a OPC-UA easy integration available, where we can export raw data to your automation system. So again, we don't require this connectivity, but we made available for you to use the raw data from our system. So in summary, this is an optimal support solution with a simple integration. So developed with a high security and accurate reporting systems that removes the usual uncertainties from the traditional condition monitoring. And it's equipped with on-demand intuitive online platform, our IoT Suite, which again makes all the literature available and documentation for easy maintenance. And it connects you direct to us on a 24/7 support, again on a click of button. So that was me. So it's a quick overview of the system. I'm sure there will be some questions. And now I'm going to pass it on to Tamian, who will explore more and do a live demonstration. Thank you.
Thank you, Leandro, for your presentation. And I will do now the live demonstration of the DriveRadar IoT Suite. I'm Tamim Badawi. I'm leading the product management at SEW, and today I would like to give you a live presentation of the DriveRadar IoT Suite. So first of all, let's have a look how to get to the DriveRadar IoT Suite. So you can follow on our homepage, go to online support, startup and maintenance, and there you will find the DriveRadar IoT Suite. What can you see in the DriveRadar IoT Suite? The application opens with a view device list. Here you can see all the monitored gear units and immediately see if everything is fine or if there are any anomalies. Each row in this table represents one gear asset. In the standard configuration of those columns, you can see for each of them from left to right the amount of warnings or errors if present, the device ID, the status, the customer designation for the gear called functional location, a link to the map on the left side, the time of the last data transmission, the serial number of the gear, as well as the installation location defined by city and plant, and last, the technical designation of the gearbox. For customer presentations like today, we operate and monitor an industrial gear unit in our showroom in Bruchsal. This is the gear unit at the top here on the first line. Let me show you briefly where this is located. I go on the map, I zoom in, a little bit more. Then I take this little man. So, you see here the large gear factory in Bruchsal, and in there is the showroom. That's where our trade show model is standing, and we can access it live today. On this exhibit, I would like to show you what is monitored within the DriveRadar IoT Suite. So, I go back. Let's have a look how our monitored gear unit is doing right now. Therefore, I click here on the table on the functional location and jump thereby to the gear unit overview. The gear overview shows me all currently recorded and analyzed values for this unit. At the top left, you see when the last data record was transferred and when the next data record will arrive. In other words, the topicality of the displayed values. The overview provides all relevant physical values of the gear, like the current ambient temperature, the oil sump temperature, the oil level, the input speed, and the vibration velocity. Next to that, you find the calculated viscosity for the filled oil and the operating hours. On the right side, there is the monitoring of all the mechanical components. We are realizing this monitoring by a fully automated vibration analysis. The scope of the monitored mechanical parts is all bearing data, such as the outer rings, the rolling elements, and inner rings, as well as all the gear wheels, according to circumferential or local gear damage. All values on this view have set limit thresholds. If one of those limit values is exceeded, then this would be indicated here by a yellow warning or a red failure traffic light. By clicking on any of those tiles, the view will change to the detail area. This is available for all values and is always structured similarly. Coming back to the operating hours, there the limit value is the planned operation time. Let's start with that. Here the time is counted in which the gear has rotated per day. In principle, in the detail area, you can visualize the measured values over adjustable time intervals. This allows you to either check the current values, for example, for the last 24 hours or last 7 days, or set a larger time interval to see trends over a longer period of time. Within the operating hours, for example, I can then see that the showroom model has been standing out of operation from end of October to mid of March. If the drive has been standing still for this long, then I'm now interested in the time utilization of this drive. I click on the cumulative values and find the utilization value in percentage. In our case, the drive runs on average only 50% of the specified time. Specified time here is 24/7 operation. We let our exhibition gear run with constant speed most of the time. The speed overview illustrates that. The customer shaft of our exhibition model rotates counterclockwise, which is why the speeds are displayed negatively in this diagram. So what we find here again is the operation profile with a gap from end of October till mid of March. In each detail area, like this one, the setted or self-learned limit values are displayed. We find the minimum and maximum values for warning and failures for each rotating direction. Of course, those values are always customer specific and can be modified at any time if wanted. Let's have another quick look into the example of oil temperature. Running with constant speed most of the time, the oil sump temperature is stable. For each time period selected in the diagram, the recorded peak values, maximum and minimum, as well as the average, are calculated automatically. If I change now the time frame, also those statistical values will change due to my selection. If any threshold for any value or mechanical component is reached, the corresponding field will turn on the traffic light. But you don't need to watch the application all the time. You can let the system notify you automatically. To show this possibility, I go to the settings area, the top right. Here you can see your stored email address, to which warnings, means yellow traffic lights, or errors, red traffic lights, will be sent. If I only want to be notified by the mobile app via push notification on my cell phone, then I can turn off the email notification here, either for errors or warnings. In our showcase gear, there are currently 2 errors. Let's have a closer look to that. So both failures are related to the remaining oil life, and I can directly jump from this list back to the gear overview. Again, there's a detail area behind that tile that explains the values and which makes it transparent how it came about this warning. This special diagram shows us the predicted course of the residual oil life. There are 2 lines in the diagram. This is because the remaining oil life depends on 2 things. On the one hand, which temperatures the oil has experienced and for how long, and on the other hand, the oil manufacturer's best before date of the corresponding oil. The prediction is always based on which date is reached first. The expiration date calculated from the temperature profile or the best before date. In this example, we have manually shortened the limits to simulate this error. All the error representation is given in the same way, and I would like to give you an example here. The above shown arrow provides a short description and the date of occurrence. Next to it, you get a recommendation for the next action. Also, the corresponding services recommended by SEW are linked here. Let's have a look to them. In this case, I can either request an oil analysis or get a quote for a new oil fill directly. If I'm interested in further services, I can also display all available services by resetting this filter. Let's say I want to order an oil analysis. I click on the Details and Service Request, and the request form will open. The form is already completely pre-filled, and it only takes one more click to send the request. I just add in the comments that it is a test from me. Sending is then confirmed by this green bar at the top of the screen. And I get a confirmation to the email address I'm registered with. I can show that email. As soon as the request has been sent, the error can be set to in progress. To do this, I update the status of the error. Of course, all events will be stored automatically in the logbook. The range of functionality is clearly explained in the online help. There are many other functions, especially related to our vibration analysis. Here we find, among other things, an explanation of how we process the vibration values. And we can learn how the system teaches itself the limit values. Finally, I would like to say that our system is, of course, constantly evolving. Today, the range of functions already is unique in the field of industrial gearbox monitoring. It offers full transparency on the fitness of all important physical variables and components of the gearbox. Predictions are being made automatically, and access is possible from anywhere and at any time. With the DriveRadar IoT Suite, maintenance in particular receives a lot of valuable information for the service on industrial gear units. The effort required for the regular inspections prescribed in the operating instructions is reduced to a minimum. In conclusion, the DriveRadar IoT Suite allows the maintenance department to concentrate less on obtaining information and much more on their value-adding doings. So many thanks to the audience. I hope it was informative for you.
Thank you, Temir, and thank you to all of our presenters. We'll now jump into the Q&A section. If you have any questions, please post them in the chat. And there's also some resources available now if you'd like to download those. So the first question I have is for Guido. Can existing gear units be equipped with the system?
Yes, in theory that can be done. There's a bit of a process. The suitability for the gear unit has to be assessed, which means this is usually done by a form that we would supply. That really covers the condition also of the gearbox. If the gearbox is already in a poor condition, it's obviously not suitable. But generally speaking, yes, it can be done.
Awesome. Leandro, are the sensors fixed?
Yes, they are pre-selected to work and the best with our software, and they are pre-selected and supplied with a package. However, we also have 3 auxiliary ports available for 3 to 4 milliamps sensors that you might require later on to be installed into integrated into the system.
A question for Tamiam. Who sets the thresholds for parameters in the system?
So some of the relevant data the customer already gives us for or when we design the gearbox, such as the ambient temperature or the minimum and maximum speed. Those limits are then stored in the digital twin. During the first operating phase of the gear, then our system independently learns further limit values, such as the oil level during the operation or the limits for vibration analysis. And then all thresholds will be automatically saved and stored in the digital twin.
Question for Guido. Do you need special types of sensors for the application?
Not particularly. No, like Leandro was already saying before, the sensors are calibrated to our software and work best with the software. So no special types of sensors. No, it all comes with the package.
Yep. How regularly do you need to maintain the sensors?
I don't believe there's any maintenance required for sensors. Not really, no.
We recognize if there is something wrong, and then if there's a demand, we can have a look at that. But usually they operate without any problem.
Yep. So a question for Leandro. Can I use the system if there is no LTE available?
Yes, it's a good question. It is possible. We can use the LAN connection via the what we call Ethernet TCP IP comms, and that would connect us direct to the internet in that case.
Yep. So Guido, we just had a question. We are using industrial gearboxes at our crushers. The person who's asked us is a crusher producer. Have you experienced the use of torque measurement, or are you planning something on this? And do you see a value in it?
I see great value. I don't believe we're planning anything at the moment, but I see very great value in torque measurement recording. There are various ways of achieving this. One is through the inverter, the amp readings. That's not as accurate though, and the other one is with real torque measuring devices. And I see absolute great value for it, and our auxiliary channels would be ideal to accommodate this, and that would really allow you then to to optimize your equipment or troubleshoot or so. Yeah, I think it's a fantastic idea.
Mm-hmm.
Just getting a couple more questions. So one has just come through. What changes are required in the gear case to accommodate the sensors?
Well, if purchased with the sensors in the first place, no changes really. If retrofitted to an existing one, there are some small machining operations that need to be done for vibration sensors, etc. Unfortunately, so it would be ideally it would have to be done in a service situation for the gearbox to come back to us. That would be the ideal situation. It could be done, can be done on site, of course, but it's just not as easy.
Are you able to give a ballpark cost per gearbox for adding a set of sensors?
I'd have to get back to whoever asked that question. I don't think we have any pricing in Australia at the moment yet. That's something we'll have to address later. Sorry.
Question for Leandro. Is the system only worthwhile as an investment for protection for larger sizes?
Oh, the quick answer is no, the size doesn't matter in this case. For instance, the physical size would not indicate the suitability of the system, but a major factor would be evaluated in the damage and probability matrix. For instance, if you have a small drive installed on a critical application, and in any case, if that breaks down, and on a breakdown scenario, it could cost thousands of dollars per day or per hour, that would make an ideal candidate to have this system installed. So it doesn't matter the size.
Awesome. So that's all the questions we've got at the moment. I'll just give it a bit to see if any more come through. Okay, I think that's actually about all time we have for questions. If you do have a burning question that you want to get answered, put it through and the SEW team will get back to you. And I'd just like to thank again Guido, Leandro and Tamiam for your presentations, and thanks to everyone who has attended today's webinar. A short survey will be sent out soon, and a recording of today will also be emailed to you. Thanks again for joining us.
All right, thank you everyone.
Thanks. Have a great day.